All right, so this is the exam review for the final exam. So question number 1 states, what is the domain of x squared minus x minus 12 over x squared plus 5x plus 4? So the idea here is, remember, for a domain, there's two rules. So you can't have negatives inside even roots. No even roots, so we ignore that. The other thing is we can't have the denominator be 0. So we want to find out where x squared plus 5x plus 4, and we want to make sure that that's not allowed to be 0. So to do that, we can factor this pretty quick. We want to find things that multiply to 4 and add up to 5. So that would be 4 times 1. And so if we use our zero product property, x plus 4 is not allowed to be 0. So x is not allowed to be negative 4. X plus 1 is not allowed to be 0. So x is not allowed to be negative 1. It's not a very good negative 1. And that's our answer. So we can have any x value except for these two. Again, the reason is because they would make the denominator 0. So that's why we don't want to pick this one, these two values. For number 2, we need to solve. So we've got a nice big fraction equation. So right now, if I want, I can factor this into 1 over x plus 3, 1 over x minus 3 equals 6 over x minus 3, x plus 3. So that's the difference of squares, so we can just break it up into x plus 3, x minus 3. So in order to cancel all the denominators out, I have to make sure that they're all the same. So over here, I've got x plus 3. I need an x minus 3. So I'm going to multiply the top and the bottom by x minus 3. Over here, I have an x minus 3, so I need to multiply the top and the bottom by x plus 3. This should be x, plus 3. That's what I'm missing. So when we do that, we can cancel all of our denominators out. So that gives us x minus 3. We distribute the 1, and we distribute that 1 there also, plus x plus 3 is equal to 6. So plus 3 and minus 3 would cancel, so 2x equals 6 when we combine like terms. Divide both sides by 2, and we get x equals 3. All right, so the one thing we have to do is we have to double check to see if it's allowed or not allowed. So x plus 3 is not allowed to be 0. So 3 plus 3 is not 0, so that's safe. So that one's okay. Now we have to do this x minus 3. X minus 3 is not allowed to be 0. But 3 minus 3, we get 0 is not allowed to be 0. So that breaks. So this isn't actually a solution. This is one of those fake solutions. This one's extraneous. So it looks like there's going to be no solution. So let's double check. Let's throw it in Desmos to see if it is a no solution. Or if we did something wrong. So 1 over x plus 3 plus 1 over x minus 3. And then on the other one, see, this isn't looking good. I think we might have made a mistake, but let's see. Let's see what we got. 6 over x squared plus 9. Squared plus 9. All right, well, it looks like they do connect right here. So they do connect. So let's see. Where did we mess up? Oh, I messed up in typing it because this is x squared minus 9. All right, never mind. I don't see any dots where they connect. They look like they connect around here. So this is right around 3. This looks like to be right around our extraneous solution. But we can see it's approaching 3 asymptotically. All right, so it looks like they never touch. This is just a y-intercept for the blue one. That doesn't really mean anything. Yeah, they don't actually connect. So it turns out in this case, we did do it right. So we got no solution. So the correct answer is no solution. All right, pretty cool. All right, let's go on to number 3. So the graph of xy equals 15 is translated up 5 units and to the left 3 units. What's the equation for the translated graph? So I want to turn this into a y equals equation. So xy equals 15. I can divide both sides by x. So y equals 15 over x. And now I can apply my transforms. So the first one I've got is up 5. So we know that I just need to add 5 to the end. Okay, that seems easy. Then I also need to do left 3. So that means I need to be in here with the x. So y equals 15 x plus 5 is still fine at the end. But if I want to go to the left 3, that means I need to add 3. And then that's in, and I don't really have anything else. So that's it. That's my final equation. So we can see it follows the pattern of y equals a over x minus h plus k. So it follows that same idea. In this case, we started with 15. So even though it doesn't say vertical stretch of 15, that 15 is there at the very beginning. So that's why that 15 is still going to be there. So that's it for 3. For number 4, which graphs have a horizontal asymptote at y equals 2? Select all that apply. All right, so C is definitely in because this is a k value. So I'm just going to pick C right away because this is just the value for k. And k is going to lift us up 2, so we'll have a horizontal asymptote at 2. Because normally they're at 0. Next one I got to check is I got to see if I divide, if I end up with 2 with anything. So if I divide here, remember I'm looking at the highest on of x's, which in this case is going to be x to the first. So this is 0x to the firsts over 1x to the first, but that's 0, not 2. So that's out. Over here, we got x to the first and x to the first. So I've got 2x to the first over x to the first, which is 2. So that one looks like that's good. Over here, I've got x to the first, x to the first. This is negative 2x to the first over x to the first. That's going to be negative 2. So that's not right. I don't want to have negative 2. I want to have a horizontal asymptote at 2. So I think B and C are going to be my 2 choices. Again, if I want to double check it, I can throw, oops, wrong one. I can throw it into Desmos and double check it. Let's get rid of those. 2 over x plus 2. I think that was it. Yep. So that's C. So C definitely has a y equals 2. Yeah, that definitely looks asymptotic there. So that looks good. I'm happy with that pick. And then 2x plus 1 over x minus 2. And yeah, that's looking pretty good too. Let's just zoom out. Yeah, that looks pretty solid as well. So I'm pretty happy with my 2 picks. I think they both work. Just to see what one of the ones that doesn't work looks like. So we got 2 over x plus 2. And we can see right there. Yep. So we hit the purple line, so that's not good. Our asymptote's just flat at 0 like we expected it because we're not really shifting it. So that's it with number 4. For 5, we have an equation to solve. This seems like a straight up question that looks like it's from Unit 2. But remember, we did a lot of these factoring things in solving all of the fraction equations as well. So to solve this, we need to make sure we get everything on the same side. So minus 2x on both sides, then minus 24 on both sides. And then we can factor. So things that multiply to negative 24 add up to negative 2 are going to be negative 6 and 4. So using the zero product property, x minus 6 equals 0. X is 6. X, that should be plus 4. So that's good. Okay, x plus 4 is 0. So minus 4 both sides. X equals negative 4. And again, we did this when we solved for our domains. I mean, we did that in question 1. So just kind of like an easier version of question 1. If I want to double check, again, I can double check this one with Desmos. Let's just see what it looks like. We have x squared, the first part, and then I think it was 2x plus 24 for the second part. Is that right? All right. Looks like, not that one. I'm going to zoom out a couple times. So at negative 4, that's at negative 4. That at 6, that's at 6. All right. Seems reasonable. For number 6, for the polynomial that we have here, which of these statements is true? Select all that apply. So the first one says the polynomial is a binomial. So a binomial means only 2 terms. So let's count the terms. We've got 1, 2, 3 terms. So that's not true. This is a trinomial. B says the degree of the polynomial is 4. So degree is always the largest exponent. So 7 is higher than 4, so 7, it should be the degree. So that's not right. So we should have 7 for that. The leading coefficient is -5. I can't answer that yet because I'd have to put it in standard form first. I guess I could kind of answer that because I know it's the coefficient that goes with the purple one. So since x to the 7th was the highest, -5 should be the leading coefficient. So that looks good. And then D written in standard form, the polynomial is -5x to the 7th plus 3x to the 4th plus 6x. I'm going to pick this one too, because remember in this case, we want the exponents to go in decreasing order. So this one would go first, this one would go second, and then that one would go last, because we've got x to the 7, then x to the 4, then x to the 1 power. So, all right, I'm picking C and D on that one. 7, r varies inversely with x. If r equals 12 when x equals 2, what's the value of r when x is -3? So we see here we're varying inversely. So that means that x times r has to equal k. So using this info, if r equals 12 when x is 2, that means 24 is k. So my equation is x times r equals 24. What is the value of r when x is -3? So -3 times r equals 24. Divide both sides by -3. R equals -8. All right, not too bad. So we just have to remember in that case, we're multiplying because we're varying inversely. Okay, not too bad. For 8, describe the transforms to translate y equals 1 over x to y equals 2 over x minus 3 plus 2. This seems a lot like a question we just did also. So this is the one that's the y equals a over x minus h and then plus k. So rational equation, we got our normal form with all of our transforms. So if we look at A, it's positive, so there's no flip. So we're not going to flip across the x-axis. Sorry, across the y-axis. No, across the x-axis. So we do have a 2 here, though. So we are going to have a vertical stretch by 2. If I look at my h value, I've got 3. So I'm going to go to the right 3. And if I look at my k value, I've got 2. So I'm going to go up 2. And that's it. So those are all my transforms. So I'm all set with this one. If I want to double check, I could graph it, but I feel pretty confident with that because we've been doing that all year. So I'm pretty good. For number 9, simplify the expression. So this is a cube root. So remember for a cube root, since this is odd, it's no plus or minus. So I don't want to write down any pluses or minuses. So we do cube root of 27. Then we'll do cube root of x to the 12. And then we'll do cube root of y to the 6th. So cube root of 27, this actually comes out nice. We could put this in a calculator if we wanted to, but we could think about it 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. This is just 3. For these ones, we have to remember when we deal with the x's and the y's, we want to take this number and divide. So we're going to do 12 divided by 3. And over here, we're going to do y to the 6 divided by 3. So final answer is going to be 3 x to the 4th, y to the 2nd. And that's it. So again, we're just rewriting our index as our denominator here to help simplify. Another one to simplify. So in this case, we need to rationalize the denominator. So we've got 6 over 2 minus root 3. So to do that, we multiply by the conjugate. So instead of 2 minus root 3, we multiply by 2 plus root 3. All right, so the top's pretty easy because we get to just distribute the 6 to both pieces. So 12 plus 6 radical 3. The bottom is a little bit trickier because remember, if we rewrite the bottom, it'd be 2 minus radical 3, 2 plus radical 3. So if you spot it, you can see this is going to be 4 minus 3 is just going to be 1. But if you want to go through the whole process, it'd be the 2 times 2 plus radical 3 minus radical 3 times 2 plus radical 3. So double distribute. 2 times 2 is 4. 2 times radical 3 is 2 radical 3. Negative radical 3 times 2 is minus 2 radical 3. Negative radical 3 times negative radical 3 times positive radical 3 is negative radical 3 squared. So these are going to cancel. 4 minus 3 equals 1. So that's how we get our 1 there. Since we're dividing by 1, the final answer is just 12 plus 6 radical 3. And we're all set. That's all we got. Pretty cool. Sounds pretty nice. Pretty easy if you got the TI calculator, since you may be able to throw it in and double check your answer that way. All right, so for number 11, graph of y equals radical x has been translated to the left 5 units and down 1 unit. What is the equation of the translated graph? So this is another one where it's y equals a. This time we're just doing the square roots of x minus h, and then outside the square root is the k, so plus k. So you see I put a big gap there. I'm even going to erase this and make this gap a little bit bigger so that the k does not go inside. You can see the k does not go inside. So in this case, there is no a. We're not doing any vertical stretches. We're not really doing any reflections. So a is actually just 1 in this case. There's nothing up here to give us anything about a. H, so we have to go to the left 5 units. So that means we want plus 5 in there. And then k, down 1 unit, means we have to do minus 1. I can just answer that way. And that's it. So another A, H, and K one. Again, if I want to double check it, I can. I could put it in the graph, but I'm good. For 12, graph f of x is the square root of x minus 2. So again, with our x minus 2 here, we see that our transform would be to the right 2. So from the center here, we're going to go 1, 2 to the right, and then we're just going to draw ourselves a nice square root. I know it's going to go there, and then 1, 2, 3, 4, 1, 2. So we can draw ourselves a nice little square root, and that's it. So we're all done. So it's important to get this point correct, and then also the end behavior correct. For 13, we have to find f times g. So now we're doing our function operations. So we've got 3x squared minus 2x plus 5 times g of x, 3x minus 2. So what we need to do is we need to distribute. So I'm going to take each piece and I'm going to distribute. So 3x squared times 3x minus 2 minus 2x times 3x minus 2, 5 times 3x minus 2. All right, so let's distribute. So 3x squared times 3x is 9x to the third. 3x squared times 2 is minus 6x squared. Negative 2x times 3x is minus 6x squared. Negative 2x times negative 2 is plus 4x. 5 times 3x is 15x. 5 times negative 2 is minus 10. All right, we'll combine all the like terms. I only have 1x cubed, so that's easy. Negative 6x squared and another negative 6x squared is minus 12x squared. I've got 4x and 15x is 19x. And then minus 10 at the end. And that's what we got. So long problem, a lot of distributing, but that's not too bad to do all the distributing. For 14, we need to find an expression for f composed with g. So if we do f of g, that means we're going to take g and plug g in for the x. So my expression is just going to be square root of 2x plus 4. And that's it. We're kind of done right there. That's all there is to it. What is the domain of f of g? So remember, we cannot have any negatives inside even roots. This is an even root. It's a square root, so we can't have any negatives in there. So that means that 2x plus 4 has to be greater than or equal to 0. So that's the way that we say, hey, I can't have any negatives in there. We have to be at least 0. If I subtract 4 from both sides, I get 2x is greater than or equal to negative 4. If I divide both sides by 2, I get x is greater than or equal to negative 2. So that's going to be my domain. I could write it that way. I could also write it negative 2 to infinity. It's your choice. Either one of these would work out as the answer. I like the interval notation a little bit more, but it's up to you, whatever you like better. And that's it. So there we go. All right, moving on. Number 15. We have h of x. We need to get h inverse of x. So remember, for our inverse, what we want to do is switch the x with the y. So we'll write this as x equals 6y minus 5. Add 5 to both sides. So x plus 5 equals 6y. Divide both sides by 6. X plus 5 over 6 equals y. That's it. Y is totally by itself, so we're all done. So just ask for the equation. So we got the equation, we're done. All right. Don't need to check it or anything with any of the compositions, so that's kind of nice. 16, we need to solve this one. So this one looks like it's going to take a while because it's a double radical. So we know we're in for a little bit of an adventure because if we have the double radicals, we have to make sure they're on different sides, which they are. And then we have to square both sides. So this side is going to become x plus 1 times square root of x plus 1 plus 1. This side, at least it's nice. At least those cancel, and we just get x plus 3. Now over here, again, we would have to double distribute. I'm going to go through the whole big process. There is a fast way to do it. You could just note the trick, but we'll go through the whole thing. Plus 1, square root of x plus 1 still equals x plus 3. All right, so double distribute. So x plus square root of x plus 1 times square root of x plus 1 is x plus 1. Square root of x plus 1 times 1 is square root of x plus 1. In blue, 1 times square root of x plus 1 is square root of x plus 1. 1 times 1 is 1. All right, I got my x plus 3 to show up. So we'll combine our like terms here. Almost. So what I want to note before I fully combine all the like terms is we've got x plus 1 plus 2 radical x plus 1s plus 1 equals x plus 3. So if we knew the trick, if we remember the trick, remember it's just going to be this first one squared plus 2 of these two terms multiplied together, so 2ab, so 2 square root of x plus 1 times 1 is this middle term, and then the n term squared would be plus 1. So if you remember the trick, you don't have to do any of this stuff. You just jump right to here. All right, so now let's combine some like terms. I'm thinking minus x both sides might actually be a good idea. It's not a minus x at all. Because that's making things look a little suspicious. So we still have our 2 radical x plus 1. 1 plus 1 would be 2. We can subtract 2 both sides. So we get 2 radical x plus 1 equals 1. Divide both sides by 2. So square root of x plus 1 equals square root of 1/2. No, just 1/2. Getting ahead of myself. Equals 1/2. Now I'm going to square both sides. So I have to square both sides again because now I need to get rid of this radical. So x plus 1 equals 1/4. Subtract 1 from both sides, and x equals negative 3/4. All right, a lot of work there. Took a lot of effort to get there, but we got there. We got to the negative 3/4. So what I need to do, though, is negative 3/4. I need to make sure that it actually works. So I do need to plug in negative 3/4. So we'll do square root of -3/4 plus 1. So I'm suspicious already because I got a negative, but you never know. Square root of -3/4 plus 3. All right, well, -3/4 plus 1 is square root of 1/4. All right, well, that's okay. So I'm back to positive, so that's good. The other side, we get square root of, so that's 12/4, so 9/4. All right, we got rid of all the negatives, so far so good. I can actually square root this, because the square root of 1 is 1, the square root of 4 is 2. Square root of 9 is 3, square root of 4 is 2. And 1/2 plus 1 is 3/2. So yeah, I'm going to keep my answer. My answer was -3/4. So x equals -3/4. That worked. All right, we're good. I'm going to double check it another way. I am going to put it in Desmos just to see if it works in Desmos too. So let's see. We've got square root of x plus 1 plus 1. And then on the other side, we had square roots of x plus 3. That is square root of x plus 3. All right, let's see. They do connect, so that's good. And they connect at -0.75. All right, so that's -3/4. So again, I'm very happy with my answer. I feel pretty good about this one. That was kind of long, but I feel good about it. For 17, we need to identify the y-intercept and the asymptote. All right, well, the y-intercept is just when x equals 0. So 2 1/4 to the 0 power. So that's 2 times 1 is 2. The asymptote would be the k value, but we're not really adding anything on here. So the asymptote's just going to be at y equals 0. And that's it. So we're all done. Again, you can graph it if you want to double check it with the graph, but I feel pretty good. Next, what is the average rate of change for over -1 to 1? So we're just going to find the slope from -1 to 1. So that's going to be y2 minus y1 over x2 minus x1. 6 minus 1.5 over 1 minus -1. So that's going to be 4.5 over 2. I'm fine with that. That looks good. 4.5 over 2. All right. For number 19, colony has a population of ants has a population of 520. Population is decreasing rate at 2.7 per year. Write an exponential decay function for the quarterly decay rate. All right. So start with our decay function, y equals 520 ants to start with. And we're decreasing, so 1 minus, and then we have a rate of 2.7, so 0.027 to the x power. Then we see we want to do quarterly, so quarterly means we need to have n equals 4, so y equals 520. 1 minus 0.027 over 4 to the 4x power. All right, there we go. So again, this is our normal form. Y equals a times b to the x. So in this case, a is 520, b is 1 minus the rate because we're decaying. So since we're decaying, that's why we have the minus sign. What does the y-intercept of the graph mean in context? It means at the start, we have 520 ants. That's it. That's just what our y-intercept means in context. So we got to think about what our start is. All right. Number 20, what's the inverse of the exponential function y equals 5 to the x power? So again, we're going inverse. So for inverse, we swap the x and the y. X equals 5 to the yth power. We'll put 5 to the y on the other side. That way we can just use the snail. Log base 5 of x equals y. That's it. Done. For 21, what's the solution to this equation? It's a log equation, so we're going to use the snail again to convert it. So we get 3 to the negative 1 power equals 2x minus 3. Well, 3 to the negative 1 power is 1/3. But from here, it's pretty nice. We'll add 3 to both sides. So 1/3 plus 3 is 10/3, because that's 9/3 plus 1 more third equals 2x. Divide both sides by 2. That's going to be 5/3 equals x. All right, so that's it with that one too. Pretty quick equation to solve. Not too bad. 22, we got to find the value of the inverse function at x equals 11. So again, that's where this function equals 11. So the answer is 2. That's about it. That's all we're going to do for that one. For 23, find the equation of the inverse. So again, we're doing another inverse, which means we have to switch the x with the y. So we'll have x equals log base 4 of 3y. If I want to use the snail, again, I have to have the log on the left side, but we can do that. So that gives us 4 to the x equals 3y. It's not a very good y. Divide both sides by 3. So 4 to the x over 3 equals y. And when we're all done there too. All right, for 24, we have to expand, so we have to follow all of our rules. So in this case, we see that we have a division, so I can turn that division, if I want, just into subtraction. So ln of a to the third minus ln of b squared c. Then I can also take this multiplication and turn multiplication into addition. I gotta be careful here. So ln a to the third minus, it's gonna be subtracting the whole thing. So ln b squared plus ln of c. So I gotta be really careful because this minus sign is gonna distribute. I'm not gonna distribute yet, but it is gonna distribute. So first, I'm gonna take these exponents, put them outside. So 3 ln of, not ln, 3 ln of a minus 2 ln of b plus ln of c. And now I can distribute. I have negative sign, 3 ln of a minus 2 ln of b minus ln of c. And that's going to be my final result. So that looks pretty good. So again, we're just using all those rules for expansion for the logs. That's what we got for 24. All right, 25, we have a geometric sequence. First thing it tells us to do is to write a recursive definition. So the recursive definition says a sub n is equal to the piecewise function something when n equals 1 and something else when n is greater than 1. But this is always going to be something times a sub n minus 1. So what goes up here is the start. We see we're starting at 2. 2 is the first term, so we just put a 2 up there. To find out what we're multiplying by, I can take any two terms and divide them. So 128 divided by 32 is 4. And so that's my equation. That's it. That's my recursive definition. For the explicit definition, we're going to use the form a sub n is equal to a sub 1 times, well, I guess we're going with r because we want to use their terms, r to the n minus 1. So a sub n is equal to the first term, which is 2. R, we're going multiplying by 4 every time, so 4. And then my exponent is going to be n minus 1. For part C, what is the sum of the first 5 terms in the sequence? Now you can do this with a whole bunch of different ways, but since it's only the first 5 terms, I gotta be honest, probably just figuring out what the last one is and adding them up by hand is going to be the fastest thing to do. Because 2 plus 8 is 10, plus 32 plus 128. So this is 10. This is already going to be 50, 60, 160. If I know that I'm multiplying by 4 every time, the last thing I need to get is 128 times 4. And that'll give me my last term. So 128 times 4 is going to be 32. 8 and 3 is 11. 4 and that's going to be 5. So if I add these three things together, I get 170, 670, 680, 682. Again, you could add it with the sigma, you could add it with the sum formula, but with only 5 terms, and I'm already giving you 4 of them, we may as well just find the last one by hand and just add them up manually. For 26, theta is going to be 2 pi over 3. We got to find sine of theta. So, all right, that doesn't seem like that's too crazy. So we're going by thirds. So those are the ones that look like this. So that's 1 pi over 3, 2 pi over 3, and then 3 pi over 3. So this is the one that we're going for. All right, so sine is going to be straight up and down. So it's positive because we can see we're in quadrant 2 over here. And then for these ones, that's going to be, this is where the 30-degree angle is. So this is the long side. So for the long side, that's the square root of 3 over 2. Cosine theta, that's going to be the short side. So that's 1/2. And since it's in quadrant 2, it's going to be negative. So again, that's just a unit circle thing. You can memorize it or derive it, but that's all we got for that one. Next one, what are possible measures for the angle shown? Select all that apply. So if we're going in the positive direction, you see we're going to go 180. And then over here we hit this. This is 20, which makes this 70. So that's going to be 250 in the positive direction. I don't see a 250 at all. Okay, that makes that easy. If I'm going backwards, I know that that's 90. And then another 20. So 90 and 20 would be negative 110. If I wanted to get to the next one, 360 degrees more, if I have to go all the way around again, I'd be at 470. So this is not going to do it. So it turns out this one only B worked out. So B was the only one that worked out. That one was close, but not quite. Angle has a reference angle with 50 degrees and terminal is in quadrant 2. So again, we're in quadrant 2, so that's going to be over here. Our reference angle is 50 degrees. That makes this 50 degrees. So we need to get a positive and a negative. So if we follow this around this way, we're going to get 90, and there's going to be 40 more left here. So that's going to be a total of 130 degrees. If I go around backwards, this is going to be 180, and then another 50. So that should be 230. Again, I could have just did 360 minus 130, but I like to follow along the circle. It's kind of fun to travel. For 29, what is sine if cosine is negative 12 over 15 and theta is in quadrant 3? So first off, we're going to do sine squared of theta plus cosine squared of theta is equal to 1. So sine squared of theta is what we're trying to find. So we'll make x equal sine of theta. So we have x squared plus negative 12 over 15 squared equals 1. So x squared plus 144 over 225 equals 1. Subtract 144 over 225 from both sides. So x squared equals, so this is 225 minus 144. That's 1. Well, that's 81. So that's 81 over 225. We'll square root both sides. So x is equal to 9 plus or minus 9 over 15. All right, so I got 9 over 15. Now I just have to decide for quadrant 3, what's sine going to be? Well, quadrant 3 is down here. Remember, sine is the up and down way. So we're below the x-axis, so we want the negative version. So negative 9 over 15. So that's where quadrant 3 is. It's below the x-axis. Almost done. 30 and 31. So these are going to use two formulas that we looked at when we did ACT review, but do deal with sine and cosine. So we're going to use one of these two formulas for each question. So for triangle ABC, measure of angle A is 38 degrees. So let's draw this out. So A, B, C. So A is 38 degrees. A is 20 inches. That's the side across from it. B is 18 inches. That's the side across from B. We need to find how many degrees B is to the nearest tenth of a degree. All right, so right away I can see my picture might not be the best. Since 20 is bigger than 18, I need this to be less than 38. So at least I know it's going to be less than 38. So if I look at my choices are going to be either the law of cosines, which I need to know 4 pieces of information. So I need to know either all the sides and an angle, or an angle and 2 sides and try and find a side. That doesn't look like that's going to help me because I have 2 angles that are important in this question. So I'm not going to use the law of cosines for this one. I'm going to use the law of sines. So sine of A, so sine of 38 degrees over A, so over 20, equals sine of X degrees, because I don't know what that is, but it is for B, over 18. And I don't really need to use this part. I can just ignore that part because I got everything I need with the first equality. I'm trying to get the X by itself, so I'm going to need to multiply both sides by 18. I could cross multiply 2 if I want, but this is going to be a little bit faster. So I've got 18 over 20. Again, I could reduce that, but I'm going to hold off on that. Sine of 38 degrees equals sine of X. And now to get the X by itself, I have to do the opposite of sine. So I have to do inverse sine. So I'm going to do the sine minus 1 of this whole thing. And so the reason I held off is I got to put it in a calculator anyway. Ooh, that's bright. I don't know. Anyway, so I'm going to put this into the calculator. You might not be able to see me for the last couple questions, but that's all right. So we got to do sine inverse. So let's go ahead and grab that. And we had 18 over 20 sine of 38 degrees. Now I got to be careful because remember, if I want to use Desmos does not start me in the right mode. So I got to come down here. I guess you can't really see very well, but there is a degree mode down here. Can I move myself? Yep. So I got to go to degree mode. So I'm going to go into degree mode down there. And this gives me 33.64. So to the nearest tenth of a degree would be 33.6. All right, rebooted this. So I thought we said that this was 33.6. Let's just fill that in again. Again, where did we get that? Right here, 33.6. So 33.6 degrees. All right, so that's our answer for number 30. All right, one more to go. So last one. So again, we got to choose between which of these we want to do. I got to move myself out of the way a little bit. There we go. So what we're going to do is use either the law of cosines or the law of sines. So in this case, the map of 3 airstrips A, B, and C is shown how far is airstrip C from airstrip A. So we're trying to figure out this right here. All right. So the important thing to remember with the law of cosines is that these letters are just placeholders. You can actually pick whichever letter you want. So since these are the B's, we care about angle B. We actually want to rewrite this as B squared equals A squared plus C squared minus 2a times c times cosine of b. Because again, we care about the b. We want the b to be by itself. So I put b where c was. I'll switch those two around. All right, so then we plug in everything that we know, which is not b. Oops. So it's not b. But we do know a is going to be 15. Doesn't matter which one is a and which one is c. I'm just going to make c bigger than a because we're used to c being bigger than a. 2 times 15 times 20, cosine of 124 degrees. All right, so this looks like it's complicated, but this is really just a job for the calculator. We're just going to type all that in. So 15 squared plus 20 squared plus 2 times 15 times 20 times the cosine of, I thought it was 138. Let me double check. Nope, 124. Way off. And so we get 289.5. Okay, so b squared is 289.5. About. Now to get b by itself, we have to square root both sides. $289.5. That's really close to 17. So we're going to go with 17. And that's it. So we're all set. So this one we just have to use the formula. So just like on the ACT, these are some formulas. You got the formulas, you just got to plug into the formulas. That's all it is just working with plugging into the formulas. All right, and that's everything for the exam review. So yeah, so all that's left to do is to take the exam. So good luck. Should be a good one.